both in order, but I get what you're going there. Maybe order is the only thing that matters in a series. I'm sorry, in a sequence.
I think it's a sequence adding, and then
Yes. The
the
sequence.
series is multiplying.
Okay, so almost. The sequence is definitely adding because we're using the sigma. We're using the sum symbol, right? And the series is just the terms, right? So I can give you a series lots of ways, right? And we'll make it arithmetic here. So I'm using curly brackets, right? 2, 6, 10, 14, dot, 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 right? So that is my sequence, right? And then my series is going to be when I'm saying the sum of a sub n, right? From n equals, let's say, 1 to 10, or a billion, or infinite, right? I can have an infinite sum as well. Will I get an answer from it? I don't know, but I could be talking about an infinite sum. So like one of the ones we had from the first class is I said the series from n equals 0 to infinity of 1 over n factorial is the number e. Right? That's one of the most special series there are. Hard to believe. The n factorial, I don't know if I talked to you about. I did put it in the video for the other class. So if you wanted to watch the second video from Wednesday, you could see the n factorial. Does anyone know what n factorial stands for? It's n times n minus 1 times an n minus 2 times dot, dot, dot. Right? So like 5 factorial is 5 times 4 times 3 times 2 times 1 times 0 factorial, and 0 factorial is 1, defined. So n factorial just means, right, all of the integers as they decrease times each other, right? So this is and the confusing piece is, well, what the hell is this, right? N equals 0 to infinity of 1 over n factorial. Well, the way you start is just start writing out terms. 1 over 0 factorial. Then the index is next is n, is 1, right? Started at 0, then 1. 1 over 1 factorial, plus 1 over 2 factorial, plus 1 over 3 factorial, plus 1 over 4 factorial, plus dot, 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 right? Goes on forever, yes? So the first time I start writing things out, I am trying to do baby steps, real simple steps, first steps. And then I'm going to try and simplify. 0 factorial is 1, 1 factorial is 1, 2 factorial is 2, 3 factorial, 3 times 2 times 1 is 6, 4 factorial is 4 times 3 times 2 times 1, so 24, plus dot, dot, dot. So it looks like I can get a pretty good answer out of this pretty quickly. Right? If I had to, I can get a common denominator here. What is this? 48 over 24 plus 12 over 24 plus 4 over 24 plus 1 over 24 plus a whole lot more. 65 over 24, right? And my calculator says 2.71. It's 2.083 repeating, but it might as well be 2.71. And if I look at E on my calculator, I get 2.718281828, and it looks like there's a pattern, but there is no pattern. It's a never-ending, non-repeating decimal, right? So 718, right? Yep. So it's pretty close, right? E is usually what we do is 2.72 for E, like we do 3.14 for pi, right? That's our kind of our adopted approximation for it. But anyway, this one's not geometric. Why is it? I'm sorry, this one's not. It's neither. It's neither geometric nor is it arithmetic. Why is it not arithmetic? Look at this particular series. Why is this one not arithmetic?
Is it because you're not like adding by a defined amount, like a set amount?
Exactly. Angel's got it. So I have to add the same constant to get the next term every time, right? So the first one I wrote down though is arithmetic, right? What am I adding every time for this first sequence that I wrote down?
You're
Adding 4 every time, right? 2 plus 4 is 6. 6 plus 4 is 10. 10 plus 4 is 14. And of course, this is leaning toward what type of function. Arithmetic sequences really adopt themselves to what have we learned in the past. Got great energy today, class. Thank you for waking me up.
Sorry.
It's okay. I'm joking. It's early.
Wait on that.
Yeah, so these things really are similar to or related to what piece of math that we've studied in the past. Like maybe even 8th grade. Certainly would have been 9th grade or 10th grade.
I want to say like, limits.
Well, you're advanced then. If you studied limits in 8th grade or 9th grade, you're advanced. But yeah,
well,
I like limits.
It was a wild guess.
Yeah. Okay. Yeah, I like limits. I like limits. There are no limits to these things that I'm talking about.
Would it be slope? Like y equals m?
Exactly, lines. Exactly. Linear equations, right? And so one of the things that we're doing in calculus, you don't have to write this down, but one of the things we're doing in calculus is we're going to learn to take a very complicated curve and find just something called a tangent line at a point, right? And if I draw a bunch of those, and you can kind of see me skiing on this hill, right? I'll put music on. So there I am skiing, and you can see the slope of my skis on the hill. And what I do is if I draw a bunch of those tangent lines, you can see that I actually create the curve from it, right? From tangent lines, from straight lines, I can create pretty complicated curves. I gotta show you one thing here. Here's my sketch pad. So why do we want to do that? Because lines are easy, right? We know how to do everything with straight lines, right? So that's kind of how we start to study very complicated curves, is by talking about tangent lines, right? Lines that are hitting one point of a curve. And now how many points do you need for a line?
3.
Yeah, we used to make you do 3, but you only need 2, right? So we had you do 2, and then we had you test the third to make sure, right? So we only need 2, but if I'm drawing a tangent line, I only have 1 point, and that's pretty hard to do. That's the basis of calculus. So what I do is I got a circle here, and I've got a line here, and I'm going to get a midpoint on the line. And notice my line is connected to the circle, right? I want a perpendicular, and I'm going to trace that. Trace. Where's trace? There it is. And then I'll move this point around the circle. Oops, I don't want the circle moving. Let me erase my traces. I don't want this line. I want a line that's not going to move my circle. There we go. So I need a midpoint. I need a perpendicular. Oops. I haven't used this in a while. And I want to trace that perpendicular. And now I move this point around the circle. And so you see I get pretty complicated curves from just straight lines. It's pretty sick, actually. This is the pattern the Earth is moving around the sun, right? Right, the Earth is on the piece of the ellipse, right, and the sun is here. So where are we right now? Right about here. Summer's almost over, or summer is over, right? We're moving toward winter, kind of thing. This is kind of cool because if I move that thing outside here, how do I erase traces there? If I move this thing outside now, move that point outside the circle, and now move the point, I get that building where Homer Simpson lives or works. You see it, the cooling tower for the nuclear power plant. So these are conic sections. We're going to try and get to them at the end of the semester. But very cool that we can use straight lines to create very, very complicated curves, right? And that's one of the things we're doing in calculus. So let's get back to the boring stuff, our arithmetic sequence, right? There's so many cool things in math, we just don't have time to show you. There's so much to do, we don't have time to show you all the cool stuff. So we had a sub n, right? The set was, what did I start at? 2, 6, 10, ... right? And I showed you a couple of ways to come up with the nth term, right? So nth term, the easy way is just to memorize that a sub n is the first term plus d times n minus 1, right? And of course you're going to put that on your formula sheet. Yes, everybody with me about when you take your first test, you can use 1 page of notes front and back. We're going to keep it. We're going to keep that on the down low. We're not going to tell my boss. When you do your second test, you want to add to it. When you do your third test, you want to add to it. So you need to be writing smaller and smaller. What I used to do when I got a formula sheet was I would take 12 pages of notes, scan them, and then make a PDF out of them. And when you print a PDF, you could say 6 pages per side, right? So, you know, you could do that at Kinko's. You could do that if you have a home printer. So this is our easy way, but let's again show that it is related to the equation of a line. We want to look at n and a sub n, and we want to leave a place for us for the zero term, right? Even though most of the time we start with the first term, we can talk about a zero term. So I had 2, 6, 10. What would be next, by the way?
14.
14, right? It's pretty easy to add 4. If it's easy to add 4, it's easy to subtract 4. So what would be the zero term?
Negative 2.
Negative 2. So I get a slope of 4, right? It's not a coincidence if the slope is the same as d, right? Like 6 minus 2 over 2 minus 1, or 10 minus 6 over 3 minus 2, or 14 minus 2 over 4 minus 1, right? Any 2 points I use, I should get the same slope. All of them are 4. And I get a b value of negative 2. And so, of course, I get my a sub n is 4n minus 2. Right? Not a coincidence that the slope is 4, right? Because I'm adding 4 every time. When n is 1, I'm adding 4 once. When n is 2, I'm adding 4 twice. When n is 3, I'm sorry, yes, that's right. But we can also look at this with our formula for a sub n is the first term, which is 2, plus n minus 1 times that 4, right? The d value is 4. Right? Everybody following me here?
Yes, yes, yes.
Thank you.
Yes.
Only 1, 2, 3, 4 of you with profile pictures. It's kind of lonely in here. Alejandro, I think, tried one too, but it's just a blank picture.
I can learn to understand you much better if I can get familiar with the way you talk.
Oh,
I need your permission to help.
Who is that? Is that Siri?
It's your computer.
My computer. Oh, it is my computer. It is. You're right. What the hell? I hate those things. So these two things are the same. I don't care which one you use. The second one, it looks a little clunky to me. But of course, if we distribute, right? If we distribute, you see that we get the same result, right? Kind of nice. I don't know why we don't teach lines that way, but that's. So one of the things we might want to do is think about this thing as recursive, right? So a sub 1 we got was 2. Our first term is 2, right? A sub 2 is 6, but we could really write that as 2 plus 4 times the 1. And then look at a sub 3. It's 2 plus 4 times the 2, right? So I'm trying to think of this thing as recursively. So, and that's this particular statement. I'm always going to refer to my next term using only previous terms, right? So I could say that a sub n is a sub 1 plus d times n minus 1. But if you think about it, right? If you think about it, right? If I say that a sub 3, look at what I get. I get a sub 1 plus 3 minus 1 times that d, right? So I get a sub 1 plus 2d. What is that? Well, a sub 1 plus d, right? What is a sub 1 plus d? How did I get my next term? I added d, right? So a sub 1 plus d is a sub...
Two differences.
A sub 2, right? So a sub 3 is really a sub 2 plus d. So here's my recursive. A sub n is a sub n minus 1 plus that d. I can always just add that difference, right? Add the 4 to my previous term and I get the next term, right? Or I can multiply d by some multiple to get and add it to the first term, right? So I can think of this thing recursively, right? This is my recursive, and I don't do a lot with the recursive formulas, right? So if you're doing problems from the book or examples from the book, you can, I'm not going to test on recursive formulas, okay? But we might need it today. We might need it today. So for one of the proofs we're going to be doing. Okay, so that's a recap of what we did last time with arithmetic. We're going to go a little bit further with it today. Okay. So, first thing we have to be able to do is find an arithmetic sequence. That we can do, I think, right? Not difficult at all. We have to be able to find the sum, a finite sum of an arithmetic, right? So finite sums. Then again, since we're in 12.2, we're just talking about, right, these finite sums. So let's take a look at the sum from k equals 1 to 7, 3k plus 5. Right? So we could do this particular thing in a very brutal way, right? Writing out the 7 terms and then adding them up. We can do it the way that we did last class, right? And that is what? Split it into 2 pieces. So 3 times the sum of k plus the sum of 5, right? And what's our formula for k?
It's n times n plus 1 divided by 2.
Mm-hmm. And our formula for the sum of 5 is 5n. And of course, we're going to allow n to be 7, right? So I get 3 times, or 3 halves times 7 plus times 8 plus 35. Is that okay that I skipped a couple steps there? Is everybody following me?
Yes.
So I get 3 over 2 times 56 plus 35. Half of 56 is what, 28? And 3 times 28, I should be able to do that in my head. What is it, 84? Yep, 84 plus 35. So I get 119.
19.
Everybody with me there?
Yeah.
Everybody comfortable
Yes.
with this? This is like your first question on the exam. Yes, Rafat.
Can we do one where we don't skip steps like back at when we had 3 over 2 times 7 times 8 plus 35? You said we skipped.
Yes. So I skipped a 3 over 2 times 7 times a 7 plus 1 times a 5 times plus a 5 times 7. I just skipped plugging in the 7.
Okay, I see.
Yep. Yeah, and please, if I ever skip steps, I even skip steps when I walk up to my apartment, you know, so I skip steps all the time. So, but if I skip a step and you need me to show it, please do. Please ask. So it turns out there's another way to get this sum, and we'll try and prove it today, that the sum of k equals 1 to n of a sub 1 plus d times n minus 1 is n over 2 times the first term plus this last term. And we'll prove that today, okay? But let's just see if it works. So we're just giving you more stuff to add to our list here, right? So, but we're going to see if this one works for the problem we just did. What's my first term? What's a sub 1, right? If a sub n is 3k plus 5, right? What's a sub 1? Well, I'm just plugging in 1 for k, right? So 8. Everybody with me? And then what's my 7th term? I'm plugging in 7 for k. So that's 21 plus 5. That's 26. And we want to see if I add these two terms here, the first term and the last term, multiplied by n, which is 7, right? 7 terms, and divide by 2, do I get the same result, right? So we want to check is 119 equal to 7 over 2 times 8 plus 26. What's 8 plus 26?
34.
Yes. So 34, 7 over 2 times 34. Half of 34 is what, 17? So 7
Yes.
times 17. And 7 times 17 is, magic number, 119. Ha. And you say, well, why do I need, if I have one formula, why do I need another formula? Because you don't know what you're going to have. If you just have the series, right? Yeah, we could do it, right? This method that we did is a method that really will come into play in Calc 1, okay? But if you just have the first and last term, you still can find the sum of the series as long as you know it's arithmetic, right? If you know it's arithmetic and you just know the first and last term, you can find the sum as well, right? So I guess I should prove that, but I'll save that for a minute here. Let me. But let's try and find another one here. Okay, so let's see what happens. Let's say I have an arithmetic sequence, right? A sub n is arithmetic. And this is example 7 in the book. And I know that the sum from I equals 1 to n of a sub n is 60 plus 64 plus 68 plus 72 plus ... and I'm going to end at 120. Right? So I'm stopping there. So the question is, well, can I find the sum? Yes, but I need something. What do I need?
N.
I need n. I don't know how many terms I've written out. Now I could brute force write them out, or I could try and figure out what n is here, right? So what formulas do I know? I know a sub n is a sub 1 plus d times n minus 1. And in fact, I know d, don't I?
Yes.
D is 4. N is unknown, right? So that's my question. D is 4. N is unknown. So I know, though, that a sub n, I know that 120 is a sub 1 plus 4 times n minus 1, and from there I can solve for n. And a sub 1 is 60, right? My dog is snoring behind me. I know I'm boring. I know I'm boring, Lucy. So what do I get? 15 is n minus 1, so this is the 16th term. Right? This is the 6th. Oh, how do I know d is 4 is the question. Thank you, Alejandra. I just see what I'm adding as I'm moving. No, it isn't always 4. Yeah. So you just got to look for the pattern. Just the first two problems I did, it was 4. Yep. And that's the funny thing about us humans is we're good at picking up patterns, and sometimes we see patterns when they don't exist, you know. And so we always want to be double checking that we're seeing that we have the right pattern, right? I used to think that only people that beat me loved me, right? So I picked up a pattern, but it wasn't a good one. So double check that that you're
Professor,
Yes.
Why did you start with the last term? No, 120.
Yeah, so I certainly could have used 72, but I would have found n is 4, right? If I picked the 4th term and solved for n, I would have got n is 4, right? So I want to remember so why do I want the last term? Because I know my sum, right, is 16 over 2 times 60 plus 120. Look how much quicker it is now. Instead of using that sigma notation, now I can just use my first term and my last term. So I've got 8 times 180, right? So this particular sum is, don't tell me, 8 times 180 is 1440. Right? So I'm giving you an alternative way of finding sums without the sigma notation. The sigma notation is really...
Hey, Professor.
Yes, Rafat.
I'm just slightly confused.
Sure.
So, do you always go with the first term, like, that's given, so like 60, and then just the last one? And then we punch out the equation?
Yep. I have to prove it to you. Right? But I had stated that if the sum from k equals 1 to n of some arithmetic sequence is n over 2 times the first term plus the last term. Right? I didn't prove it yet. I'm going to prove it. And the proof is very similar to the way I proved the sum of the indices. Remember the Gauss proof. I wrote the sum forward, I wrote the sum backward, I added them. Right, so the proof is very similar. So this is the game is I'm going to tell you the first term and the last term, and I want you to find the sum for me. Right, that's the game. So pretty simple. Pretty simple game. Should we do another one?
Sure.
Yep. So I've got an arithmetic sequence, okay? And I'm going to give you the 4th term and the 20th term. I want you to find everything you can. So this is in the textbook, by the way. This is number 32. So 12.2, number 32. And you can always do problems from the textbook. I like the problems in the textbook that are odd because they have answers in the back of the book. You can find the answers. I guess I should give you answers, right? If any of you are doing problems from the textbook, I have the homework solutions for all of the problems. So I'll give you those. Just let me know if you need them. So this is number 32. It says the 4th term is 3. And the 20th term is 35. So what do we want to find? It's arithmetic, right? I'm in 12.2. Everything's arithmetic. A sub n is arithmetic. So what do we want to do? Well, we want to find several things. A sub 1. We want to find n. We want to find d. Well, we don't need to find n. We know we're going up to 20. And we want to find the sum. So we'll find the sum from 4 to 20. Right? So what do we have? We have several formulas, but our main formula is...
We're going to use the one from like A1 plus n minus 1 times d,
exactly.
And then we do like simultaneous equation.
Exactly. So we're going to use this guy a couple of times, right? How many variables do we have there? Well, we have 4, kind of, right? But we take care of a sub n and n with this information. So meaning when I have a sub 4, I know I have a sub 1 plus d times 4 minus 1, right? When I have my 4th term, I know the 4th term is 3, and I know the n value for the 4th term is 4, right? So this particular thing equals 3. So now look at how many variables I have. I only have 2. So I'm going to do that again, a sub 20. I'm going to get a sub 1 plus d times 20 minus 1, and that's going to be 35. Okay, so there are my 2 equations I'm going to use. And so now I'm back in Algebra 1 doing a system of equations, right? So help me here. I've got a sub 1 equals 3d, plus 3d equals 3. Everybody with me here? And you're going, well, how am I?
Yeah.
How was I supposed to know how to do this, Robert? And I'm saying, well, I'm doing it now. You're supposed to know, right? So, and then I also know that a sub 1 plus 19d equals 35, right? So here's my system of equations, simplified a little bit. And obviously I can subtract them. I'm going to subtract the second minus the first, right? So I get a sub 1's go away. I get what 16d equals 32. So d is 2. I did that quick. Make sure you're okay there. Right? I did. So this is equation 1 and this is equation 2, and I got equation 2 minus equation 1, right? I did equation 2 minus equation 1.
Just real quick, why can you subtract the equations from one another?
So this is something we did in Algebra 1, but it's basically saying you've got two people, one taller than the other, and you take the height of the taller one and the height of the lower one, and you get the difference in their heights. And so it's a little bit more complicated than that. You got one line, right? You've got one line and another line, and you're subtracting one line from another line. The height thing is the easy one to understand. The line one is not as easy to understand. But basically, we're taking those two pieces that were up in the air and moving them down onto the ground, right? We're taking this height here, and we're just putting it here and saying, oh, that's the actual height you had, the difference in the heights. I don't think that was a good explanation of it, but I've never thought of why can you do that. But here's the real truth. If you have two things that are equal, I'm sorry, if you have two quantities, can you subtract them? Yes, always. So, and basically I'm subtracting two things that are equal on the left, and so then I also have to subtract two things that are equal on the right, and I should still get something true, right? That's a better explanation. All right, I got D. How can I find a sub 1? Well,
You plug D to the one of the
exactly. Well, I know a sub 3 is 3, or I could use a sub 20, and now I know D, right? So a sub 3 is 3 plus 2 times n minus 1, right? I'm sorry. Oh, sorry, equals. Sorry, a sub 1. I'm sorry. A sub 1 plus 2 times n minus 1 is my a sub 3. That's 3, right? Sorry about that. And so I can solve this for a sub 1 now. So a sub 1 is 2n minus 2. Oops, a sub 1 plus 2n minus 2 is 3. Oh, shoot. And I know n, don't I? Sorry. I'm screwing it up. It won't be the first time. I am human. I know D is 2, and I know N is 4. Sorry. Right? A sub 4. Right? My fourth term is 3. So A sub 1 plus 2 times 4 minus 1 is 3. There it is. I'm sorry about that. So A sub 1 equals, plus 6, right, is 3. So the first term must be negative 3. Sorry about that. I know I confused a bunch of you. Start again, right? A sub 4. They gave me a sub 4. So now I know what n is in that case, and I know what d is because I just figured it out. And I could plug it into my formula to find a sub 1. Either formula, right? So what else do we want to find? I had said we want to find a sub 1. We did. Right, that's negative 3. We found D, that's 2. We want to find the sum. So the sum from n equals 4 to 20. Remember, we have our fourth term and our 20th term, right? of a sub n is 16 over 2. Is that right? Times 3 plus 35. Am I right? 16?
Why 16?
How many terms do I have from a sub 4 to a sub 20?
16.
Yep. So 8 times 38. $304. And I mean, I'll just do this because I'm worried I have it wrong. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Right? So it's 2, 4, 6, 8, 10, 12, 14, 16, 17. I did have it wrong. It's always the difference plus 1. 17 over 2, so 17 times 19, sorry. 323. So to get n, right, how many terms I had, I could do it a couple of ways. I could subtract the 20th term and the fourth. 20 minus 4 is 16, add 1 to that. Or I could just do, right, I know that a sub 20, to find out, no, that doesn't make sense. It's always, right, so 20 minus 4 is 16, and if I add 1 to that, I get the number of terms.
So we can find the nth term without the first difference.
Yeah. Now this, so a sub 20 is the 20th term, right? But I started at a sub 4, so how many terms did I skip? That's an easier way to do it, right? I skipped a sub 1, a sub 2, a sub 3. It's confusing, and I know I confused you. We'll do another one, and you'll be fine. This is find the first term to come. We'll do another one of those, right? The 5th term is -2, and the 13th term is 30. It won't be the first time I confuse you or make a mistake. Don't worry about it. Life goes on. Life is difficult enough. Math doesn't have to be. If you make a mistake in life, it could be the end of the world. But if you make a mistake in math, it's not. So a sub n is arithmetic. This is number 36. 12.2, number 36. A sub n is arithmetic. And I know that a sub 5 is -2. A sub 13 is 30. Let me give you a minute. Find me d, find me n, find me the sum from the 5th term to the 13th term. Oh my God, D is 4 again. I didn't want that to happen. Hey, Joseph's here. Good morning.
Good morning. I have been here the whole time.
Oh, you just got your profile picture up. I guess once you logged out and then came back in, it put it up there for you. Sorry, Jeff.
I haven't been here the whole time.
Oh, okay. It doesn't matter anyway. I'm recording. I'm going to take attendance now. So we're working on this problem right here. This is number 12.2, number 36. Did you use 4? Anyone else get 4? Alejandro, that was an accident that it turned out to be 4 again.
And the first term is minus 18.
Thank you. Anybody agree? Anybody confer? Anybody lost? No, you're on Earth. You're not lost. So how many terms do I have there from the 5th term to the 13th term? Well, I skipped 4, right? So I have 9 terms.
Right.
Yeah, so I'm looking at the sum from n equals 5 to 13 of a sub n, and I know I get that with 9 over 2 all times the quantity of negative 2 and 30. So 9 over 2 times 28. So 9 times 14. 146? No, 126. 126, yeah. To the author, Alex, I'll show you after class if you want, okay? Lexi, Alex.
Okay, thanks.
Yep. I guess I should prove that I can get the sum from the first term and the last term. Do you want to see the proof of that? Proof is kind of nasty.
Excuse me, I have a question.
Yes, I'll help.
Where did the 9 come from?
Yeah, so if I'm thinking about the whole sequence, I've obviously got the 13th term, right? So that would be 13 terms. But how many did I skip from a sub 5? I skipped 4 of them. So 13 minus 4 is 9. Right?
Okay, got it. Thank you.
The proof is there. We don't have any math majors, right? The proof is kind of, I'll do it, but don't write it. How's that? Okay, I'll do a quick proof, but don't write it down, right? Is that okay with everybody? So,
Yeah.
Yeah. So I want to prove, right, that the sum from n equals 1, k equals 1 to n of a sub k is n over 2 times a sub 1 plus a sub n, right? I'm trying to prove that. Right? And a sub k is arithmetic. I think it's obvious that a sub 1 is the first term and a sub n is the last term. Hey, Skip is here. Skip, you okay? You're muted. You're walking, making me dizzy. Let me know when you're set, okay? So I'm going to prove this using the sigma notation, right? So I'm really I'm going to say that a sub k is a sub 1 plus d times n minus 1, right? And I want to look at the sum of that, right? So the sum of a sub k is the sum of a sub 1 plus d times n minus 1. And I'm sorry. Lexi, you okay?
Oh, yeah, sorry, I was talking to my...
No problem. So I know that I can distribute the sum, right? I can get the sum of a sub 1, and I can get the sum of d times n minus 1. Skip, you all set? You're muted. You're muted.
Can you hear me, sir?
All right, there he is. So I don't know if you can see the whole class. Hi, Skip. This is Robert. Skip Mahaney is our embedded coach. So if you can all give him a quick hello. I think he can only hear us.
Can you hear me,
yes,
Professor?
Yes. Can you hear me, Skip? I can hear you. Can you hear me?
I guess that's a no.
I think that's a no. Can you hear me, Skip?
It does not appear to be working.
Your volume might be down, Skip. Yes, I can hear him.
I must have a bad connection, sir.
No problem. Why don't you...
Can you hear me now?
I can hear you. I've been able to hear you. Can you hear me?
Oh, I'm sorry.
Yep. Can you hear me?
Yes, I can now.
Okay. All right. So everyone,
How have you been?
I'm great. So we're right in the middle of a proof, but I still would like you to introduce yourself to the class. So
hello, class. My name is Ralph Mahaney. I have been a professor at Montgomery College since 1981. I'm getting long in the tooth, but still love what I'm doing. And so now I am coaching in some of the Math 165 classes, in case you don't have enough time with your professor, and he has an awful lot of material to try to cover in 14 weeks. So if you would please come to my sessions. I'm available on Monday, Wednesday, Thursday, and Friday from 10 o'clock until 4 with no appointments, but I will take first come, first served. Try to limit the discussions to 15 to 20 minutes and see if I can help you with some of the material that you are presently learning. This is the first week, and now is the time to get involved in your education. Don't wait until you're so far lost that you have no idea what's going on, because at that point, we have to play catch up. Does anyone have any questions?
That's great, Skip. And I've got your Zoom information posted on Blackboard, so the students can get there and get some help from you.
Excellent.
Yep. And so it's right there in number 4 on ways to get extra help in the class. And I like what Skip said. If you don't have enough time to meet me, or if you need more help after you meet me, right, then you're going to call on Skip. So
Absolutely.
yeah, and I'm trying to get them to help each other. So there's lots of ways for them to get help. So we're doing sequences in series right now, but
Okay.
I want to make sure if anyone has questions for you, Skip. Anyone have questions for Skip?
No.
They're a real talkative group. I think half of them might be half of them might be asleep.
Well, when you get us in the morning, there's not much energy to go around.
I understand. So Skip, thanks a lot, and I hope you can join us for the 12 noon class later too as well.
Yes, and I would also like to come to your 1:30 if I may, but that probably will be next week.
Yes, Tuesday or Thursday. You're welcome to come anytime.
Thank you, sir.
All right. See you later.
You have a good day.
Thank you.
Class, you have a good weekend. Bye-bye now.
So, back to my proof. So anyway, Skip's been at the school for a long time. He's very kind. He'll be very, very gentle and go slow with you if you need the extra help. So I want to distribute this D value, right? I want to distribute this D value. Oh, and I should be using K here. I've made a mistake, but it's okay because you're not writing it down, right? This is a K. So I'm going to distribute that. So I get the sum of A sub 1 plus D times the sum of K minus the sum of D. So I distributed that D and I distributed my sum, right? Well, I know the sum of A, it's N times A1, right? And I know the sum of K, it's N times N plus 1 all over 2. And I know the sum of D, it's ND, so minus ND. And again, you're not copying this, you're just watching me and making sure you agree with everything I'm doing, right? So I took the series, wrote it as my my formula, right? I'm splitting it into sums, right? Distributing the D, and now using my formula for the summation, right, notation. What I'm going to do is, notice I have an N and everything. I'm going to factor that out, and I'm going to factor out a 2, right? So I'm going to factor out the N and everything, and I'm going to factor out the 2 and everything. In order to factor out a 2 from the denominator, when it doesn't exist, I have to double the numerator. So I got 2 times A sub 1 times D times N plus 1 minus 2D. So that's a little bit weird, but if I distribute that 2 back in, right? If I distribute that 2 back in, notice it'll cancel here. It'll go back downstairs there, and it will cancel here, right? So it's easier to think of that factoring in reverse. I'm going to distribute my D again. I get ND plus D minus 2D. And then I notice there that what happens, I have an ND minus D, right? 2A sub 1 plus an ND minus D. So I can factor out a D now, right? I can factor out a D there. I get N over 2 times 2A sub 1 plus a D times N minus 1. Oh, we recognize D times N minus 1, right? Now I'm going to split my two A sub 1s up. I've got an A sub 1 plus an A sub 1 plus a D times N minus 1. And guess what this last piece is? Guess what that last piece is in blue? Anybody know? It's my last term, right? Remember, that's how I generate every term, and N minus 1 is the very last one. So that's A sub n. Okay, we're done with 12.2. I want to do a little bit of 12.4, but if you have any questions, let me know before I move on. Who's in charge of the Discord?
That would be me.
Okay, and how many students do you have on there?
I can check. I think I have like 21 last time I checked.
Okay, so we're supposed to have 24 students, so it's okay if you don't want to join it. I don't see why it would hurt to join it, but
I have 23 students in it currently.
okay. So I might have 23 in the class because I've only got 22 showing up today. I do appreciate when you tell me you're going to be absent. I know it can't happen all the time, but you know, that's why I'm recording. Any questions on the content? Yes, it's a little confusing. You got to just jump in there and do some problems. That's all. That's what it takes. And ask for help, right? You can email over the weekend. I will try and answer. We don't have class Monday, so you've got 4 days to work, right? Let's see, Wednesday. Yes, today Friday. Yes. I want to do a little bit of work in 12.4. Okay. So 12.4 here we're doing, and this is proofs by induction. And the key here in proofs by induction is that the process is pretty simple. Whether you agree with it or not is a big question. So my computer scientist students really should be able to know how to do this. You're going to do it again in discrete structures, Math 207, or computer science. What is it? CMSC? What is computer science code? Doesn't matter.
CMSC.
CMSC 207. They're the same class. So whether you take it with a computer science professor or with a math professor is the main difference. I'm hoping to be teaching it next semester on Tacoma Park. And so by the time you all get there, hopefully it'll be my third semester teaching it, and I hope to see you in that class. So proofs by induction. I will not require the homework here. If you're a computer science major, I would ask you to try it. If you're not a computer science major, you don't have to try it. But if I give an extra credit on this first test, it'll be a proof by induction. Okay? And of course, you can just skip it and still get 100 on the test. So the whole idea is we want to show a particular theorem, and for us it's going to be a sum. Show it's true for 1, maybe show it's true for 2. Why not? Show it true for 3. And so now I'm thinking it's going to be true every time, right? It's kind of like, the sun rose on Wednesday, the sun rose yesterday, the sun rose today. I think the sun is going to rise every day. Now that one turns out to be false, right? We know this thing's going to burn out in some time. At some time, our sun is going to be gone. So, but we are for mathematics. We think this thing, since it was true for 1 the first day and the second day and the third day, we think it's going to be true forever. So what we do is assume it's true for some time later and try and show it's true for the very next time, right? So here's our whole process. Show the equation true for n equal 1, maybe 2, maybe 3. Assume it is true for some value k, and show it will be true for k plus 1. So assume that the sun is going to rose today, it's going to rise tomorrow, it's going to rise the next day. Assume it's true sometime later in the world, in the universe, and see if it happens the very next day, and then we know it's always going to happen, right? That's the idea. Of course, it fails for the sun example. But it's not going to fail for the sum of k equals, I equals 1 to infinity, 1 to n of I as n times n plus 1 all over 2. Now, we already know this is true, but we're going to do it now by induction, right? We saw a simple proof of it. We're going to now prove it by induction. And I've only got 7 minutes, so this is going to be the only one I do today. You don't have to do, I'll do some more on Wednesday. So really, we're just talking about homework 1 and homework 2, 12.1 and 12.2, okay? You can read the section on 12.4. We're not doing 12.3. You can start reading chapter 2, right? We're going to go right to chapter 2 on after I do some more induction problems on Wednesday. I'll start chapter 2 on Wednesday. Skip did mention there's a lot of material. There is a lot of material. So it's never going to stop, right? So we want to stay on top of it because it just keeps coming. The material just does not stop all semester. But our goal is to be ready for Calc 1, to get an A or a B in this class, and then possibly get a B or not worse. You don't want to get, C's are not good. C's are fine. You get to graduate with a C. You get to move on with a C. But you're missing 30% of the material, right? So I already know that this particular thing is true. So here's my proof. I know from I equals 1 to n of I, that's 1 plus 2 plus 3 plus ... plus n, and that should be n times n plus 1 all over 2, right? So let's look at the sum for n equals 1. Well, what am I talking about? The sum from I equals 1 to 1 of I. That's just 1. And is that 1 times 1 plus 1 all over 2? Yes. So it worked. It worked for 1. Let's see if it works for 2. The sum from I equals 1 to 2 of I is 1 plus 2, and that's 3. But is that 2 times 2 plus 1 all over 2? That's 2 over 2 times 3. Yes, it's 3. Check, it worked. So it seems to be working every time, right? So what I want to do is assume it's true for k. Assume the sum is true for k, for n equals k. So, Lexi, yes? So, meaning 1 plus 2 plus 3 plus ... plus k is k times k plus 1 all over 2.
If this is too loud, I can mute myself.
Yeah, you can mute yourself when you're not talking, but you can feel free to talk whenever you want. So, so the trick here is, and this is the trick every time, okay, so this is the magic, is you have to think about the next term and add it everywhere. So I'm going to assume this is true, and the old joke is if you assume things, you make an ass out of you and me, but this is how we prove things. We have to assume something. So we're going to assume that this particular sum is true, and here's the trick, and I'm not writing this down, I'll write it down next week. Find the next term and add it to all of my equation. So what comes right after k? What's the very next term after k?
K plus 1.
Exactly. The next term is k plus 1. And so my trick is to add k plus 1 here, to add k plus 1 here, and to add k plus 1 here. And what I'm going to do with this is manipulate it, and I should show it's true for k plus 1. Okay, so let's look at what happens. When I add it here, I'm no longer summing up to k. Now I'm summing up to what? k plus 1.
Plus 1.
Yep. And here, I just have what's there, 1 plus 2 plus 3 all the way up to k, all the way up to k plus 1. But what's true over here is I have k times k plus 1 all over 2 plus a k plus 1. All right, so that's what I'm going to manipulate. I add the next term, and I'm going to manipulate this right-hand piece every time I do one of these proofs. So I'm going to factor out, if you see, I can factor out a k plus 1. I can factor out a k plus 1. And what do I have left? I have k over 2 plus 1. And I'm going to get a common denominator there. So I have k plus 1 times k over 2 plus 2 over 2. And I can factor out the 2 now, so I have k plus 1 over 2 times a k plus 2. Guess what? Remember, I had to prove the thing true for k plus 1. I have to prove it. I assume it's true for k, and I have to show it's true for k plus 1. I have to assume the sun will rise in the year 2052, January 2nd, and show it rises on January 3rd of that same year, right? So I want to notice that if I say that n is k plus 1, notice what do I have here? I have an n. And what do I have here? K plus 1 plus 1, so that's an n plus 1. And that's my proof. And there it is. Same thing I wanted. N times n plus 1 all over 2. All right, we're out of time. I know you might be going, what the hell just happened? Maybe even with the whole class. But I'm sure you'll be fine once you do some problems. Have a great weekend. Enjoy Monday off. And get some homework done. Okay? I'll stick around if you want to talk. If Lexi, you want to see how to do that profile picture.
Thank you, Professor.
Okay.
Have a great weekend.
Thank you. Thank you.
So, Professor, this class we essentially just went over 12.2, and then this 12.4 bit.
Exactly. We did 12.2, and I started 4. But again, 4 is going to be